Okay, I'm gonna do the number thing one more time real quick, just for the video, because that's the part that cut off. So again, -1 to +1. What's the highest number of correlation?
1.
1 or -1. It can't go to 1.05. It can't go to -1.05 or anything like that. If you get a question that has numbers and they say which is the strongest correlation or which is the weakest correlation, pay attention to the question. And it looks something like this. I know this is a repeat for you guys. Etc. What is it? C, because it's closest to 1 or -1 without going over. When you have one of these, just don't look at the sign. If it goes over 1, it's incorrect. The closer you get to 0, so -0.1 or +0.1, it ends up being no correlation or a very weak correlation. The further away you get from 0, the stronger the correlation. Okay? So a correlation of +1 is going to look exactly like a straight line going this way. A correlation of something like 0.8, which is also really strong, is probably going to look kind of like this. The closer it is to 1 or -1, the more likely it is to be a straight line or closer to a straight line. If you have one that looks like this, it is no correlation. Okay, that's pretty much what we just went over, right?
Yeah.
Sorry, the video stopped. Okay, is it still going now?
Yeah.
Okay. So I guess individual videos have like a maximum running time or something?
Yeah.
Okay. It wasn't much.
Okay.
Okay. So we just went over this. Okay, remember p-value. P less than or equal to 0.05 means that the study is statistically significant, which means it's not likely that it was due to chance. Good, you guys remember. Or you see that. Okay. So p-value has to be less than or equal to 0.05. You'll see if you end up majoring in psych in college, you'll notice that a lot of times they'll use a p-value of 0.001, which is even stronger. So I think it's 0.001 or 001. I think it's now I forgot. It's been a while, but there's even a stronger p-value than that. But this is good enough to show that it's statistically significant. So then we're on to validity and reliability, okay? Validity means the study is valid. The study measures what it's supposed to measure. So let's say you're doing a study and you have confounding variables, you have extraneous variables that you didn't account for. Is the study going to be valid? No, because it might not measure what it's supposed to measure, right? Like let's say you're doing a study on a student's grades and the amount of time he or she spends studying, okay? And then you have, like, the way you conducted the study, you happen to have the students who are taking regular level classes, maybe in one group, and the students taking honors classes in the other group, and that's going to confound the study. So you're not, in fact, measuring what you sought out to measure in the first place, okay? So that's validity. You have to have the experiment. You have to sample correctly and assign the subjects correctly and create the operational definition correctly and all that stuff in order for it to be valid. Reliability means that if you conduct the same experiment again, and that's what psychologists do, they replicate the experiment. So if you repeat it, then you're going to end up with roughly similar results. Okay, so the R in reliability should remind you the R in repeat or replicate. Okay, questions? What happened? Do you want me to repeat? Okay. Range. Range, again, you got to put the numbers in order. It's the highest number minus the lowest number. So you have a set of data. Here's a data set right here. The highest number is 13. The lowest number is 2. If you subtract 13 minus 2, the range is then 11. Okay? And still going? Variability. Variability basically means like if it's high variability, the data is very spread out from the mean. It's kind of like a large, wide set of data. If it's low variability, it's all around the same value. Okay? So variability means like a lot of the results come in the same. High variability means that there's more like spread between the results, basically. Standard deviation is kind of similar, but it's the average distance from the mean. So should we go over this real quick?
Yeah.
Okay. So here's our data set. This data set kind of works nicely. I know when we get to here, there are like a couple different things that, or there was squaring or not squaring. Let's just do it this way, we should be fine. So the first thing you're going to do is you're going to take the data set, actually I'll do it in black, and you are going to, step 1, find the mean. Okay, so let's add them all together and divide by how many they are. So 4 plus 2 is? 6 plus 2 is?
8, 16, 20.
20. And how many values are there?
5.
So what is the mean?
4.
4. Okay, so we found the mean. Next one is find each difference from the mean. So what are you going to do?
Subtract.
Minus 4, minus 4, minus 4, minus 4, minus 4. 4 minus 4 is?
0.
2 minus 4?
-2.
2 minus 4? 8 minus 4?
4.
And
0.
okay, we did that. Next step is you're going to square each difference. Okay, so does it matter if anything's negative?
No.
No, because you're squaring everything. Okay, 0 ends up just being 0, right? -2 squared is?
4.
And again?
4. 16.
And then 0. Okay? Yeah, I made sure to put those there. I forgot. We need to put those there because they're still values. So when we divide again, we need to make sure we know that those are values. Find the mean again. So we're going to add all these up and then divide by the number of values, which is 1, 2, 3, 4, 5 again, of course. 4 plus 4 is? Plus 16 is? Okay, so that's the mean. Okay, so that is called what? The variance. So when you get to this point, you've found the variance. And then finding standard deviation is very easy. You just square root the whole thing. Okay? So finding the variance, it's funny because on that test, I mean it's not funny, but on that test that I gave you guys, a lot of people found the standard deviation and then didn't know the variance, when in fact they had found the variance, they just didn't know it was called the variance. So once you get to this point, before you square root it, this is the variance, okay? And then you just put the square root thing and that's it, you found the standard deviation. So it's not that hard. It's got, a lot of steps, but 5 steps, I mean, you guys did more than that in geometry doing proofs, so it's not that bad. Yeah?
Doesn't it say square root of variance?
Yeah. That was the variance, and I square rooted it.
Oh, I thought, because it's in standard deviation sometimes. Yeah, but it's just.
Am I right? I'm right, right? I'm good?
I guess so.
Yeah. So we found the variance, and then we square root it. See, like that, and that's standard deviation. Yeah, square root the variance.
We're not doing the n minus 1.
You don't have to. I just feel like this is easier, so.
It is.
They're both correct in different ways. If there happens to be a standard deviation question on the AP test and you do this, you'll get it right.
Okay.
Yeah. Okay? Questions? I'm gonna let you guys copy it for a second. It's still running? Okay. This is going by really fast, huh? Okay, we're almost done with chapter 2. So after that is the bio chapter, chapter 3. Chapter 4 is sensation and perception. Chapter 5 is consciousness, and chapter 6 is learning. What do you guys want to do after chapter 2? Because we might not get through all of it. I could do till maybe like 12:15 if you guys want to stay a little bit more. But I gotta get back and feed Will. So. What do you guys think? Bio?
We did chapter 5 and 6 exact reasons, so we don't.
We did just do chapter 5 and 6, so it should be pretty fresh in your head.
What was 4?
Four with
4 was sensation and perception, so we can try and do 3 and 4.
Let's just do 3.
Bio is
Okay.
hard too.
Bio's heavily weighted, so bio would be a good option. And it comes next. Can I erase that?
Yeah.
Okay. Bio will probably, even though it's a lot, it'll probably go by fast because you have a lot of it memorized. So, okay, normal distribution. So the 99, what was it? The 99, 95, 68 rule? Is that what it's called? Okay. What was it?
99, 95,
68. Okay. So 99, okay, so 99.7% of people, so this is in a normal curve, which IQ is a perfect example. 99.7% of the whole population is within 3 standard deviations from the mean. So for IQ, if the mean is 100, 3 standard deviations away would be 55. So 99.7, the vast majority of the population is between 55 and 145 for the IQ. If they're outside of 145, like let's say their IQ is above 145, that's very, very rare. I guess you'd kind of consider it like an outlier, sort of.
Are they good or bad?
To have an IQ that high?
Yeah.
I guess it depends on how you look at it. I mean, it's good. You're obviously very, very intelligent, but a lot of people who have IQs getting to be like really, really high sometimes, I don't know, maybe get frustrated easily or something, or I don't know. It depends on how you look at it. So, okay, so 95% are within 2 standard deviations, and 68% are within 1 standard deviation. So 68% of the population has between an 85 and a 115 IQ. Again, this is memorization. So if you remember 99, 95, 68 rule, and I still have trouble memorizing that, just know that 99 is 3 standard deviations away, 95 is 2 standard deviations away, and 68 is 1 standard deviation away on both sides. Okay? So, again, if you get this on the AP test, it'll be 1 question. And it's not going to be on the free response. Okay?
Will the standard deviation be
It's possible. It's possible. I don't think so. But you never know. They might give you an experiment and be like, here's the scenario, here are the data results. Yeah. But this, no. I don't see that. This is a multiple choice type question, 1 question. Okay? Alright, skewed distribution. So remember the Bill Gates example? So Microsoft, most of the people make like, I don't know, 60,000, 70,000 or something. And then you have Bill Gates, or actually, yeah. And then you have Bill Gates who makes like way more, right? Which moves the data. So the data's pulled to the tail of the whale. Okay, remember that? And in a skewed distribution, you don't want to use the mean because the mean is affected by those extreme scores. Even though most of the people make 60,000, when you have Bill Gates making, 2 billion, the mean is going to look a lot higher, so it's going to look like people make more even though they don't. Okay? So in a skewed distribution, you want to use the median or the mode. The median is probably your best bet. Okay? All right. In a study, and it's actually interesting, my father-in-law was telling me about this. They're doing a study on, remember I talked to you guys about immunosuppressors? So they're doing on a new drug, a new kind of immunosuppressors for people who are getting heart transplants. And so he was telling me how, like, yeah, they get, there's a placebo control group and an experimental group, and even the doctor doesn't know who's in the placebo, who's in the control group, and who's in the experimental group, because the way the doctor acts toward the patient, that could, affect, and I'm thinking like, yeah, I know this stuff, I teach it, and so a perfect example. So the fact that the doctor is administering the drug, and he doesn't know if he's administering the drug to the control or the placebo, he doesn't know if he's administering the placebo or the real drug to the patient. So that is a double-blind study. Because that way the way the doctor talks to the patient doesn't influence the way that the patient feels. Okay? When you have a single blind or you're not double blinding the study, the way that the doctor or anyone who